Welcome back to this lecture series on deep learning. In this lecture, we'll discuss some machine learning basics under this what is capacity, overfitting and underfitting. We'll see one by one. First, what is network capacity? What does it mean? The capacity of model refers to its ability to learn and approximate a wide range of functions. A high capacity, that is a high capacity means this can represent complex relationship between input and complex relationship between input and output data, which is essential for solving difficult tasks. And model capacity affects how well the model can capture the patterns in the training data and generalize them to new situations. If the capacity is too low, what will happen means it may not generalize well, and also it is leading to a poor learning outcomes. Capacity is low means this may happen in this case. When a model has low capacity, it may be too simple to capture important patterns in the training data. This causes the model to underfit, which means it performs poorly even on the training data it has seen. Next, a model with high capacity can learn very complex relationship between inputs and outputs, making it effective at training. However, this also increases the risk of overfitting, where the model learns details specific to the training set that don't generalize. In simple terms, the capacity of model controls the likelihood of underfitting and also overfitting or overfitting. A balance in model capacity is necessary to ensure that it learns general patterns without memorizing the training data. Next, how to control model capacity. The number of nodes in neural network layer is called, we can call it as number of nodes in the neural network, we can call it as the width, number of nodes. We know that the neural network consists of input layer, many hidden layers, and also output layers. How many nodes are there? This we can call it as width. More nodes means the model has more units to represent different patterns. More, suppose input is having n number of nodes, n patterns we can represent, giving it more power to learn complex functions. Next, the number of layers in the neural networks, input layer, output layer, and the hidden layer and output layer, we may be using many hidden layers. So the number of layers in the neural network is referred to as depth. By increasing the depth, we can stack layers of computation, which allows the model to capture more complex hierarchical patterns. Next, to increase the model capacity, one can either add more layers, that means depth, or increase the number of nodes per layer, that means width. Both strategies make the model more expressive, allowing it to represent a larger variety of functions. So a deeper neural network has greater representation power and can learn more complex patterns. Interestingly, increasing depth can also be more efficient than trying to achieve the same with just a wider, shallow network. Next, overfitting. That means if the model is learning much, what will happen? Overfitting occurs when a machine learning model performs well on training data. This may be performing well on the training data, but fails on new or test data. This means the model has not generalized well and instead learned patterns specific to training set. In overfitting, the model starts to memorize the training data, including noise, irrelevant data, or details. So it may be including the noises also. This results in high accuracy for seen data but poor performance for any new or unseen inputs. A classic sign of overfitting is a model that scores very high accuracy in training but performs significantly worse on validation or test data. This gap between training and testing performance is a major problem in real world application. That means overfitting means your model is too smart for the wrong reasons. Next, causes of overfitting. The one major cause of overfitting is the presence of noise or irrelevant values in the training data set, as I've said already. If the model tries to learn this noise, it becomes too specific and fails to generalize to clean or new data. Next, overfitting is often result a high variance model. It has a high variance in the model where it becomes overly sensitive to, even if it has been fluctuating in a small amount. The small fluctuations, it may be overly sensitive in training data. This is the disadvantage of this case. The model adjusts too closely to sample in a sample instead of finding a general rule. Using too little data to train a model can also cause overfitting. How means a small data set might not contain enough representative models, and the model may memorize the limited data instead of learning general trends. So, overfitting also occurs when the model is too complex for the task at hand. A complex model can easily learn intricate patterns, but without enough constraints or data, it may latch on to noise. Next, how to prevent overfitting. One way to control overfitting by using k-fold validation. This means which helps assess the model's performance across multiple splits. Multiple splits of the data set. This ensures that the model performs well on different subsets of data. This we are calling it as the k-fold cross validation. Next, regularization technique such as L1 and L2, we can call it as this lasso technique is L1 and rich is L2, introduces penalties for large weights in the model. These techniques help prevent the model from becoming overly complex by discouraging extreme parameter values. Next, training the model with more data can provide better generalization. This will provide us the better generalization. A large data set allows the model to see more patterns and reduces the chance that it memorize noise or irrelevant details. Next, ensembling techniques like bagging and boosting and combine multiple models. This will combine multiple models to improve overall performance. These techniques reduce the variance and help the model generalize better to new data. Next, so this generalization is the key and not memorization. Next, underfitting. That means if the model is learning too little, what will happen? So the underfitting happens when the model fails to learn underlying patterns in the data. Even during training, it cannot capture the trends that connect input to output, resulting in poor accuracy. This type of model cannot generalize well because it never properly learned from the training data itself. It is not just for failing on new data, it is also failing on the data it was trained with. An underfit model is usually too simplistic, missing out on important relationship in the data. This is often due to overly high bias, where the model assumes the data is simpler than it really is. So, underfitting is like showing a complex movie to someone who slept through it. Next, causes of underfitting. Training data that contains irrelevant or noisy values make it difficult for model to learn important patterns. The model gets confused by meaningless inputs and underfits the data. Next, underfitting is frequently caused by high bias in the model, meaning the model is too rigid or makes overly simplistic assumptions about the data structure. If the data is too small or lacks diversity, the model won't be exposed to enough patterns to learn from. This results in weak training and leads to underfitting. A model that is too simple cannot represent complexity of real world data. It fails to capture relationship and performs poorly on both training and test sets. Next, how to fix underfitting. Adding more relevant features. This will overcome additional, that is, gives the model additional information to learn from. This helps it build a more accurate understanding and of the relationship in the data. And increasing the model capacity allows the model to capture more intricate patterns in the data. This may include adding more layers, using advanced architectures, or incorporating future transformations. Next, cleaning the data set by removing noise. How we are going to clean if you are removing the noise or irrelevant data helps the model focus on meaningful patterns. A clean data set improves both training and testing performance. Next, training the model for more time gives it more chances to adjust its parameters and reduce error. However, this must be done carefully to avoid overfitting. So let the model see more, learn more, and think deeper. Next, what is a good fit? A good fit occurs when both the training and the test errors decreases over time. This means the model is learning general patterns instead of just memorizing the data. Next, as the model trains, the error on the training data typically goes down. If the model is learning well, the test error also decreases, indicating good generalization. If the training continues too long, the model may start to memorize the noise in the training data, causing the test error to increase. This makes the point of overfitting. So this will causes the overfitting. So to achieve a good fit, training must be stopped at the optimal point. Training must be stopped at the optimal point. This is very important point. Just before the model starts going into the overfitting. Before going into the overfitting, we have to, if we are finding the optimal point, we have to stop training. Monitoring validation loss can help identify this moment. Next, what would be the final thought of the above discussions? Fit right, not fast. That means the performance of a model depends on various factors, including capacity, training time, and the quality of data. A well designed, balanced among these is important for good generalization. A model that is too simple often results in underfitting. Okay. It cannot capture essential relationship in the data and fails to perform well even on training data. On the other hand, highly complex. If the model is highly complex, model can memorize the training data leading to overfitting. This hurts in ability to perform well on unseen data. So the ideal model lies in between, not too simple. Ideal model would be not too simple, not too complex. It learns just enough from the training data to make accurate predictions on new inputs. So the goal in machine learning is to design a model that generalizes well. This means learning meaningful pattern without memorizing irrelevant details. Coming into the conclusion, a successful machine learning model requires a careful balance between model capacity, data quality, and training time, that is, training duration. If the model is too simple, what will happen? It may underfit the data, failing to learn meaningful patterns. On the other hand, an overly complex model can overfit. complex model, overfit, memorizing noise. Noise also will be memorized and performing poorly on new data. This ideal model lies in between, one that is just complex enough to capture the essential relationship while still being. What will happen? Still being able to generalize well to unseen inputs. Achieving this good fit ensure the model performance accurately, reliably, and effectively in real world scenarios. So ultimately, the smart learning comes from choosing the right model capacity, using clean and sufficient data, and training the model just enough to avoid both extreme. What are all the two extremes we have seen? We have to avoid overfitting and also the underfitting. We have to balance. So in order to achieve the balance, we have to find out the optimal value to stop, to go for the either overfitting or underfitting. So the smart learning comes from right capacity, clean data, and controlled training. Hope everyone understood the what do you mean by capacity, what is underfitting, what is overfitting. So if you wanted to learn about more about underfitting and overfitting, you can watch my previous lectures that I have used it in AI ML concepts. The remaining things we'll discuss in the next lecture. Thank you.